Let's talk about multiplying and dividing with zero and negatives. So first off, multiplying and dividing with zero. These are just things you pretty much have to memorize, but there is a reasoning behind them. They make sense if you think about them. Anything times zero is zero. So if you think about that, you're adding 0 plus 0 a times, you're still always just ending up with 0. 0 divided by a is 0. So we're taking nothing and dividing it into a bunch of groups of nothing. So the groups are, it's still nothing. A divided by 0 is undefined. So you're dividing, you have some amount and you're trying to divide it into groups of 0, but you never use up the thing that you're trying to divide out because those groups of 0 aren't actually affecting it. So but yeah, anytime you see 0 as a factor, then the whole product that the 0 is a factor in is 0. And then there's no which is which of 0 divided by a is 0 and a divided by 0 is undefined. The undefined, you can kind of think of it as infinity, depending on the context, where you would have infinitely many groups of 0. But for our purposes, we'll just say undefined. But there will be some contexts where thinking of it as infinity makes sense. All right, so some practice calculating. So 3 plus 7 over 5 minus 5. When I do those additions and subtractions, we get 10 on top, but 5 minus 5 is 0. Doesn't matter what's on top really at that point. As soon as the bottom is 0, that result is undefined. Negative 4 plus 4 is 0. And at that point, it doesn't matter what's on the bottom. It does matter a little bit. If it's 0 divided by 0, it would be undefined. So at least make sure it's not 0, but 5 minus 3 is 2. 0 divided by anything is 0. So again, just a matter of remembering which is which of those. So more practice here where we have an expression with x in it and we're thinking about it if we plug 0 in for each x. So 0 plus anything doesn't change it. So when we have x plus stuff, x minus stuff, and we replace that x with 0, you kind of get in the habit of the x just disappears. So we have a 3 and a minus 5 and a 7 getting cubed. But the x squared out front, doesn't have anything being added, it's subtracted to it. So when we plug 0 in for that, because it's being multiplied by stuff, it doesn't disappear. It makes the whole thing 0. So at that point, it doesn't even matter what else is there. So when you see a bunch of factors, doesn't matter how many factors there are. When x itself is one of the factors, you plug in 0 for x, the whole result is 0. Next example, we have x times x plus 1 over x minus 2. So on the top, x is a factor, the whole top is 0. On the bottom, you have x minus 2, plug in 0. It's not 0, so that's all that matters there. The whole result is 0. X squared minus 3x plus 4 over x squared minus 3x. We have end up with just 4 on top because the x squared and the minus 3x just go to 0. But the x squared and the minus 3x on the bottom just go to 0 also. And we have now 4 divided by 0, so that one is undefined. All right, and then sign rules, basically how negative signs work with multiplication and division, because a negative sign really can be thought of as multiplying or dividing by -1. Then just like multiplication can be reordered, that negative sign can move around from factor to factor or from up or down in a fraction. So a times negative b is the same thing as negative a times b is the same thing as the negative of the result of a times b. Negative of a quotient, so negative a over b is the same as a over negative b, or the negative on the top with a, so the negative a over b. And then two negative signs in a product or quotient cancel out. So negative of negative A is A, and also like negative A over negative B would be positive A over B. Those would cancel out as well. So we're mostly, this caused confusion. It was with the fraction. So if I have negative of 3x minus 5 over x minus 2, then that could be the negative of the whole top over the bottom, not negative. So again, a negative sign can be applied to the top or to the bottom. So leaving the 3x minus 5 as is and applying it to the bottom. You don't want to apply it to both the top and the bottom, because then those would cancel out and it would just get rid of the negative. And you also don't want to just stick the negative at the front of the top or the bottom. It needs to apply to the whole group. So remember, the top and bottom of a fraction, they don't have parentheses written, but anytime as you start doing anything with them that involves multiplication or division, those parentheses, that whole thing is grouped. So put parentheses if at the point where you need them. All right, so we get then negative 3x plus 5 over x minus 2, or 3x minus 5 over negative x plus 2. Those are the correct possibilities, or just leaving it as is. But so negative 3x plus 5 over x minus 2, that one's okay. Negative 3x minus 5 is not okay. That's one of the ones we said wasn't good. So we've switched the sign on the 3x, but not on the minus 5. No good there. 3x minus 5 over 2 minus x. 2 minus x is the same as negative x plus 2. So that's my second option that was correct, with the 3x minus 5 unchanged. And then negative 3x plus 5 over negative x plus 2, that's applying the negative to both the top and the bottom. So that one's no good. So just make sure, really, you can just leave it if you have something like this. If that's your final answer, just leave it like that. Don't try to move the negative around. So where it more matters is if you're subtracting, the subtraction would apply. Typically we'd apply it to the numerator, to each term in the numerator that's being subtracted. So that's sign rules, multiplying and dividing with 0 and negatives.